Fetal and Placental Development by Tori Cummings, Nadine Elnell, and Michael Serafino. The main task for this project was to determine what kind of function the graph that was given displayed. We had to determine if it was a graph of the original function, wt, its derivative, w prime t, or its second derivative, w double prime t. Once that was determined, we used the newly found information to help find other components and interpret the data into a physiological perspective. Basically, this means we wanted to graph everything, this way we could compare and contrast. The first graph we created is Figure 1, which is titled Fetal Growth Rate Data. This graph looks at fetal rate of growth, which is in grams per day, versus the time of inception, which is in days. So the x-axis is time after inception, which the unit is days, and then the y-axis is fetal rate of growth, which the unit is grams per day. The second graph is Figure 2, which is titled Placental Growth Rate Data. This graph looks at placental rate of growth versus time of inception. On the x-axis, we have time of inception, which the unit of measurement is days, and then the y-axis, the placental rate of growth, in which the unit of measurement is grams per day. So, after reading through documents and looking over the graph, we concluded that the data displayed was the derivative, and here's why. Reading the documentation and reviewing the information provided, we've concluded that the data displayed in Figure 3.1 is the derivative of the original function w prime t. We came to this conclusion through the use of the paper's context. It states that the growth rate of the fetus and the young infant were displayed through the use of two techniques. One is the absolute growth rate, which is the change in weight per unit of time, and the other is the relative growth rate, which is the change in weight per unit weight with time. It is stated that Figure 3.1 shows the absolute growth velocity of the fetus and placenta from the 16th week of gestation to the 25th week. Since velocity is the speed at which something is moving, and the unit being used for growth of the fetus, and on the y-axis is grams per day, which can also be seen as the rate of growth. We've concluded that the graph is displaying the derivative. On this graph, we have the fetal rate of growth in grams per day on the y-axis, and then time of inception in days on the x-axis. Here you can see the data increasing from 0 to around 250, and then an outlier in between 250 and 300 days, that is, and then you can see the data slowly decreasing from 300 and on to 450. This graph, on the other hand, shows placental rate of growth in grams per day on the y-axis, and then time after inception in days on the x-axis. Here we see the placenta of grams per day shown as red dots, and you can see the data slowly increasing and then slowly decreasing. You can see the point of inflection around 175 days. Using the trend lines for both sets of data, we've determined that the polynomials that fit the data best were the ones set to the fourth degree. The fetal polynomial is as follows, and the placental polynomial is as follows as well. Figure 3 is labeled as fetal growth data, w double prime t. On the x-axis is time of inception in days, and on the y-axis is rate of fetal growth in grams per day. The inflection points for the fetus can be seen at 104, 0, 295, 0, and 430, 0. The development of the fetus is increasing at an increasing rate, but once past the first inflection point, the rate of increase begins to decrease. meaning that the fetus is developing at a slower rate because it is in its final stages of development before birth. Once it reaches birth, the fetal development decreases. It increases again due to continued development as an infant. Figure 4 is labeled as placental growth data, W''T. The x-axis shows time of inception in days, and the y-axis shows rate of placental growth in grams per day. The inflection points for placenta can be seen at 112.517, 0, 189.966, 0, and 244.557, 0. The placenta is constantly gaining weight up until the point of birth, though it is also losing weight in smaller intervals as it gets to the point of birth. Figure 5 is labeled as fetal weight data, WT. The x-axis shows time after inception in days, and the y-axis shows fetal rate of growth in grams per day. This graph is pretty linear, as a fetus grows in a linear rate, slowly developing as the weeks go by. Figure 6 shows placental weight data. The x-axis shows time after inception in days, and the y-axis shows placental rate of growth in grams per day. This graph is also very linear, as a placenta grows parallel to a fetus. Since the fetus grows linearly, slowly increasing after each week, the placenta would grow alongside, as the placenta surrounds the fetus.